Okay, sorry for being very late. I think we can finish today's the remaining standalone. So cuma hari ni saya tak bawa. I didn't bring the extra monitor, so maybe difficult for me to ask the question by list the name, the list name. Tapi okay, dah ada. Sekejap eh. Okay, dah ada nama. Alright, less than less than half. It's okay lah. Okay, sekejap eh. Lepas ada bunyi ni. Ada lantern. Sekejap eh. Yang problem tu. Okay. So, I forgot until what level, what part we have learned. Tapi we have gone through the design of the standalone system. So, kita akan proceed. We proceed for the remaining part. Okay. So, we are now going for the battery sizing and selection. Sorry, today I don't have the webcam. So, when we talk about the standalone system, the most appropriate system is by having the storage batteries. Having storage batteries, then it is possible for us to use the electricity during the night. Okay, during the night. And then, so the choosing of the battery or the selection of battery will be limited by what is on the market. To be honest, if you ask me what type of battery we have here, we have a lot. You just have to scroll all the Google and scroll all the websites to find the appropriate size battery based on your needs, and also the price also you can check. Okay. And then yeah, of course, each person have their own interests as their own selection, as their own favorite brands, as their own bias for using the batteries, choosing the batteries. So it's totally subjective. So identify the available batteries, list important capacity that can fit within the budget. I think if you don't have problem with the budget, I think the things that we are going to see is the characteristic of the battery cell. Okay. We have calculated before the required capacity of your battery. Calculate the required capacity of your battery. The capacity of the battery required depends on three primary factors. Just now I think last week we have calculated the daily charge requirement. Okay, the daily charge requirement is the ampere hours. How much ampere hours that we need for a day if we use this kind of what call that? If you use this kind of loads, okay. So the daily system charge requirement must be supplied to the loads, okay. So this is the target lah, the daily system charge requirement. So if we don't calculate this, that originally come from the loads, how many hours you use for the load. So it's originally derived from that. If we don't calculate this, then I believe you will face the problem of insufficient energy storage during your operation. Definitely, you're going to face that. Okay, because you don't plan anything, so you just proceed buying everything here and there and use whatever you want to use. Then suddenly, oh, the battery storage battery is not enough. It's not enough. It's our fault actually. Okay. Then there's one more factor that vary for me is I'm not sure whether of for those who have touched the batteries. I'm not sure when you get used with this. We call that as the depth of discharge. The maximum allowable depth of discharge factor is DOD max. It's DOD. It's the depth of discharge. Okay. This is the deepest depth of discharge that is ordinarily allowed with the battery. Shallow cycle batteries, for example, should not be cycle below 20%. Sorry, this is B. Okay, should not be cycle below than 20% that will discharge, while keep deep discharge battery. Deep discharge battery or deep cycle battery can regularly handle 50% discharge. In other words, the battery that we look, I mean the battery capacity, total capacity that we look, for example, is 100 Ah. You frequently see this. 100 Ah with 12-volt batteries. Please don't think that we are not what I allow. We are capable to use the totally 100% of 100 Ah. It's actually, if the lead acid battery, I mean the lead cycle, it's actually by considering the DOD with the 50%, actually we can use safely is 50 Ah only. Okay, 50 Ah only is the effective, the actual effective capacity that we are capable to use actually. Okay, even though we buy the battery of 100 Ah, I mean I'm talking about the lead acid battery, deep cycle lead acid battery, it only can discharge up to 50% or 60% only, which means that if we have the battery of 100 Ah, then maximum safe discharging rate is on the 50 Ah, half, based on the DOD written in the data sheet. However, the deep meaning of the DOD also still I'm still question. Uh, but actually, when we try it, actually we get more than 50%. Because I have tried before. The capacity of the 40 batteries lead acid, for example, we can get confirm even more than 30 when we do the testing. Even though we have full charge the batteries, mean the highest voltage go to 14.7, almost 15 volt. We charge until that level. Then when I start to discharge using the battery tester and so on, then we get the maximum capacity, I think around 26 to 27 maybe. It now goes even below more than 30. Okay. The safely can discharge to half okay, 50% then okay, slightly over than that maybe 60%, 50 to 60%. But the most safest side to be taken, to be considered for the deep cycle DOD for the lead acid battery is 50%. Okay, what are the meaning of deep cycle? Okay, deep cycle is actually, I think, the lorry battery, or the PV system battery, or you can see that totally sealed battery with the high capacity at 100 sometimes 200 So that is the deep cycle. What is the shallow cycle of the battery? Even though in the same class of lead acid batteries, 20%, the example is the motorcycle battery. Okay, motorcycle, car, that battery. That one only can go up to 20% only. Okay. Please don't use the car battery as a replacement to use for your solar system. Okay, because it's very shallow and it's not deep. Okay, cannot be discharged even more than 20%. Okay, you need to buy the dedicated battery, which is the lead acid battery, even the AGM type, gel, that lead acid battery, or VRLA, valve regulated lead acid base battery. That one is the example of the deep cycle battery. Okay, so first thing, to choose the battery, we need to have the daily requirement of AH per day, the daily system charge requirement. That's the first factor. Second is the depth or discharge of that battery that we are going to use or to buy. Normally 50 to 60%. Then I think lithium phosphorate, I forgot the name. That one can goes to 70 to 80%. I don't have the picture here now. There's not the lead acid base, but there's the lithium base. Okay, lithium base battery. And the third factor Okay, the third factor is the reserve storage factor. Okay, reserve storage factor or system autonomy is the numbers of days of storage needed. It's very site and it's higher for site with cloud weather. This is the system autonomy means that how many days you want it to withstand if weather condition is very bad. So that battery will become the main source of energy that will supply the energy to the load that we have designed. Okay, so how many hours, how many days of backup? Okay, this is what we call system autonomy lah. If we want 3 days, so we need to multiply with 3 days lah. Of course lah. For example, we calculate the stainless system charge requirement, we get 100H. But we want it to withstand for 3 days. So means that if 3 days unstoppable raining, so the system can withstand to supply all the lighting, or the maybe the fan, or maybe the air conditioner, for example. So that how many days? So means that if more days you need to reserve, there will be more storage battery, more multiples. You need to multiply the capacity. So it means that more budget will be needed to buy extra batteries. Okay, that's what we call system autonomy. So minimum number of battery, dengar saya ke? Ke saya cakap seorang diri? Jamadil. Ashraf.
Ya doktor, dengar.
Dengar? Alhamdulillah. Apa lagi nak? Ustaz. Farhana. Farhana, dengar ke? Faham ke? Ada Gilan. Hasif. Hasif.
Ya.
Boleh
Boleh.
Boleh lagi
Boleh.
Fatin Adawiyah. Boleh saya.
Ada doktor.
Alhamdulillah. Tak boleh saya ni, saya tak boleh diam ni, kena panggil umur. Okay. So minimum number of battery, admin battery. So when we say minimums, of course lah, the final answer will be round up lah, logically. Okay. So this is the admin battery. Okay, minimum number of battery is the we call that as the battery requirement, capacity battery requirement. Required capacity. The things that we are going to calculate is the required capacity. By considering the daily system charge requirement, the DOD, the system voltage, and also the number of reserve days that we want to put. We want the system to withstand. So that will conclude as the required capacity for the system that we are going to install. So this is the total capacity, or this is the minimum number of batteries that we need in order to fulfill our desire. Okay, yang kita design tu lah, desired design. Okay, so the equation is very super simple, not simple lah. I mean, it's related from the before. So here come the again required daily revised. I mean the latest after we considering the all inverter factor, inverter efficiency, generosity efficiency, that equation lah. So energy required, I mean the required energy requirement lah. Okay, how much is the ampere hours? How much is the watt hours that we need, and that watt hours after considering all the losses over the this is the system voltage. If we use 24, then 24 lah. If we use 12, then 12 lah. If we use 28, 48 lah. Then the DOD max, it depends on the brand and depends on the question. Given information given in the question, for example, standard lead acid battery can goes to 50 to 60%. Okay, maybe I read there 55%, for example. Then if we use the lithium based phosphoride apa benda semua tu, lithium based battery tu, that one maybe for example can goes until 75 to 80% for example. So the DOD maybe the right here is 75 kan. So the DOD is the 75 or 0.75. Okay. Then multiply with the reserve storage factor or system autonomy. So how many days that we need the system to withstand if something happen. So this the usually very useful for the system that are placed in the jungle, in the forest, in the mountain, on the mountain, everything. People who try to isolate themselves from the public, because they are maybe too much stress living in the urban, living in the city. So they are isolating themselves to the jungle, in the jungle. They want to become like the Tarzan, so they want the system withstand for several days. So that one will totally reflect to the storage capacities of the battery, which is more cost will be spent. Alright. And then N battery parallel mean the number of battery in the parallel. Okay, in the parallel is about the charge. I mean the total capacity, storage capacity will be parallel. In order to get more capacity, then we need to parallel our battery. So the C battery requirement is calculated from here. From there, then we over the capacity of our battery that we use. For example, we use the 100 Ah battery or we use the 200 Ah battery. So replace is with 200. If this, for example, this calculation we get, then we multiply, we divide it to 200, then we are going to get 5.3 batteries, for example. Okay, 5.3 battery. So that one will be minimum number of battery. So it will be round up. Okay, will be round up. And then for the series, it's very super straightforward. Number of battery in the series is the supervisor over the battery voltage. If the battery we use usually the lead acid or so on, typical value is 12 volt. But let's say our system is 48, then the number of series is 44. Sorry, 4 series. If for example this is 1000 Ah, then battery that we use is 200 Ah, that means that we need 5. Usually not this beautiful value lah. If you say 979 for example over 200, maybe this is close to, for example, 4.7 something, which is close to 5. So it's round up. If we round down, that will be not enough storage capacity for the system. Okay. Boleh, until this level boleh ke? Aku pula mengantuk ni.
Doktor nak tanya.
Yes.
UMP ada tetapkan tak berapa safety factor untuk UMP?
Ulang balik, UMP?
Safety factor, value.
Safety factor, have safety ke?
Tak. Kalau dalam
Safety margin.
Kalau minta safety factor, UMP ada tetapkan tak value yang UMP guna untuk safety factor.
Safety factor, alamak. Safety factor apa ni? Untuk, tak faham, saya tak faham soalan awak, saya tak faham. Safety factor UMP tetapkan apa ni? Safety factor untuk apa ni? Batteries?
Dalam pengiraan untuk apa-apa safety. Biasanya kan ada value untuk safety factor. UMP ada value tu tak?
Margin ke safety margin ke? Saya tak dapat get.
Ya.
Safety margin untuk apa? Untuk GCPB ke standalone? Pengiraan apa-apa ke? Macam tu?
Secara general lah.
Okay. Clear sikit. Soalan kau tu bagi clear. Sebab saya tak clear. Soalan awak tanya ni menjurus kepada apa? Penggunaan bateri, number of module ke? Apa benda ke? Ke ada size ke? Macam mana ke?
Secara general dalam untuk solar system.
Okay.
Untuk UMP ada tetapkan tak value tu. Berapa dalam 2 ke, 1.5 ke?
Factor tu?
Ya.
Setakat ni macam tak ada. Sekarang macam tak ada lah. Ada spesifik tu. Kalau untuk sekejap aku mesti tak dapat lagi soalan kau. Untuk installation ke? Untuk apa ni? Untuk PV punya limitation ke? Kalau dalam pengiraan grid connected tu, itu safety margin yang lain. Tu yang kita letakkan berapa, 95% ke, then 10% untuk lower voltage ke. Itu untuk case yang tu dia tetap kau ada SEDA. Kalau standalone memang ada SEDA certified. Dia ada SEDA punya guidelines. Cumanya yang kita follow ni, kita tak follow yang SEDA punya lah. Kita yang untuk yang standalone ni, kita ikut yang berdasarkan rujukan, beberapa rujukan lah. Tapi tak follow yang betul-betul SEDA punya lah. Dia agak detail sikit lah. So dari segi limitasi untuk menggunakan storage bateri berapa banyak ke, itu tak ada limitasi. Cumanya kalau standalone ni dia tak ada restriction sangat. Standalone sebab dia tak kacau grid. Bila tak kacau grid system ni, dia tak ada isu dengan TMB, tak ada isu apa benda. Cumanya the way kita pilih tu as soon dia tidak memudaratkan lah. Maksudnya design yang kita, pemilihan kabel kita tu, that's different thing lah. Tapi nak kata ada safety factor, kalau standalone ni biasanya dia lebih terbuka. Tapi kalau grid connected mesti ada PPA, ada power purchase agreement, dan dia mesti ada involvement of the TMB, sebab TMB adalah buyer. So yang tu tidak boleh suka-suka hati kita cocok beli grid inverter, cocok terus kat sistem kita, letak PV meter sendiri, tak boleh. Itu mestikan perlukan kelulusan daripada SEDA. Kota tu dapat SEDA, and then the PPA, daripada dah sign PPA semua tu, yang tu baru buyer dapat berapa dan sebagainya lah. Untuk yang as soon kalau siapa yang ada bajet lebih, ada kapasiti lebih, dia boleh buat lebih, tak masalah. Setakat ni belum ada limitasi lagi. Untuk standalone tu saya tak nampak ada limitasi lagi. Tapi kalau grid connected tu tak boleh main. Sebab dia kacau grid kan. Dia akan kacau grid.
Okey, baik.
Menjawab soalan ke?
Jawab.
Cuma ni tadi tak ada lah. Tak ada, kalau untuk standalone tak ada restriction pun. Sebab ada yang saya kenal, adalah beberapa pesyarah yang terlibat dengan projek yang ada yang fully standalone, ada yang Selco, dan dia memang ikut dan dia punya load. As soon dia, sebab dia tak kacau TMB punya meter, so TMB pun takkan kacau. So dia tak ada restriction kat situ lah. Cuma kita masih memegang pada agama Islam lah. Kita bukan syariah tu, ada restriksi tu. Maksudnya tak ada limitasi lagi lah, setakat ni. Tidak ada regulation, larangan semua tak ada. Standalone, kalau nak pasang Selco, contoh Selco lah. Selco nanti saya usik sikit kot, sebab nanti nak tunjuk kat benda tu. Yang tu sebab dia dipasang selepas meter kan, meter TMB kan. So dekat DB kan, tu dia TMB tak kacau orang lah. Tu ikut pandai mu nak buat benda. Tapi kalau apa jadi short skirt, insurans cover tak cover, tu cerita lain lah. Macam tu. Boleh Ashraf? Umum soalan ni. Soalan ni member of parliament soalan lain soalan umum. Okey, betul macam ni. So yang inilah, yang capacity inilah yang saya rasa mungkin ada keterlepasan pandangan lah. If for those who newbies yang doesn't have any basis about standalone, but they have budget and they have interest and they have the spirit of renewable energize the world, so they buy the PV and they want to put the PV on their rooftop so that they can show off to others and to the neighbors, and then but the problem is they just assign someone who we don't know where it comes, and we don't know anything. Then maybe that brother who claim that he's very expert, lot of project do, but maybe if they don't consider this kind of calculation, you can question, because the problem is the battery will be insufficient. Seriously, if for example, if you wrongly use the system voltage, for example, your load is more than 4 kilowatt hours, but you use only 24 volt. I believe it will be insufficient during the operation, especially for those who use the heavy loads like the air conditioner, iron, or the water heater if possible lah. And plus another one, they don't consider the DOD. DOD very critical. It means that if 50%, 50% means if you have the battery 100 Ah and if you want the real capacity, actual capacity of 100 Ah, you need to buy two. You need to have the 200 Ah total capacity bought, original capacity bought from the batteries. You need to buy two pieces, not only one pieces, because the DOD is there. Even though our return capacity is 100 Ah, we can't think that we can use 100 Ah. No, that's the the misconception. You must think that even though we have 100 Ah, we actually can use 50, slightly more than the 50 lah, maybe less than 60. That's our limitation. To be safe, we take half only, 50%. So means that if you want to use 100 Ah, for example, 100 Ah multiplied with 12 volt, then you're going to get 2.4 kilowatt hours load. Just the rough numbers. You need to use 2.5 kilowatt hours. I mean, you have the load of 2.5 kilowatt hours. It's not enough if we use this, because actual is not 100, it's 50 only, because DOD. Then we need to have two pieces of batteries. In calculation, you get 4.8, but actual one we got only half. So if buy two batteries, connect it in parallel, then you're going to get the 200 Ah. That's why here comes the N battery parallel. Remember, if you parallel the battery, then you are going to get more capacity. The capacity will be multiplied. And this connection is quite risky and dangerous, because it can create not only spark. If you make mistake, it can lead to the unnecessary accidents. Because I have experienced before when I was in PhD. So because it's connected, everything is connected and very close. So when we try to remove, for example, you have the connector between two batteries. We try to remove one. Then while I'm removing that, even I'm using the glove, everything, but suddenly when you use sometimes you use spanner, wrench, or sometimes you use the screwdrivers. The connector also rotate. When rotate, it touch to the next battery and boom, in front of me. That one is lithium ion battery. But luckily, nothing happened to me. Just the culture shock. But you can see some smoke in the room. Sebab tak apa-apa, major sangat lah. But that one is quite high capacity, 40 Ah for each battery. The risk is here. The risk is here. When we connect parallel, I think parallel. If we connect in series, I think series still okay kot. Series still okay because it's not looping. Series you just connect, so they okay kan. Series connection, so you just connect here to here, here to here, and then here to another battery kan. Then load positive and minus kan. So that one okay lah, no problem at all, because everything is can be easily isolated. But if you try to connect in parallel, parallel ni, then satu bateri ni, so you akan connect sini kan, then connect sini. At the same time, yang ni ada pergi ke load, yang ni pergi ke minus kan, tapi you parallel. So why parallel? Because looping it's closed loop. That one very dangerous. Sometimes we use the breaker in the middle. Breaker in the middle, at least we can isolate while connecting the wire, while doing the parallelizing, so at least they don't have any working, running current between the batteries. Tu agak risiko if we use the parallel. Please wear glove, please wear, be aware with that insulator. I mean, If you have the wrench, then you tape it with the insulator tape. Okay, so you touch the insulator instead of barely touch the wrench because it's made by the ferrum iron. So very dangerous, or aluminium, very dangerous. So you need to uh, wrap the wrench with the insulating tape. Then you touch it with your glove. Okay. You okay ke ni? Ke aku cakap korang lagi lah. Senyap je korang ni. Kenapa ni hari ni? Kenapa kat korang ni? Semua lemau ni apa hal ni? Okey ke? Ain, Nur Ain okey ke? Nur Ain ke Nur Aini? Okey ke? Tak dok. Saya tak nampak lah nama nak panggil. Amirul. Ingat Amirul ni.
Okey, Doctor.
Okey kau tidur. Dah lama tak Roger pasal ID je tiba kan. Okay. Alright. So this example, battery specification, I don't put the real picture, just the example lah. So depth of discharge usually for the proper battery they written also data sheet, but not on the battery. You need to find the data sheet lah. Okay. That written 60% or 50%. By default, deep cycle we can take 50% safer side. Don't take less than that. Less than that, it's not worth. So 50% to 60%. I think 60% still okay. Okay. Mostly battery voltage is 12 volt. Okay, 12 volt base battery, and battery capacity depends totally depends. They have 100, they have 300. Okay, depends on the brand. Okay. In order to get the minimum required capacity, minimum charge battery, minimum required capacity C battery, we have the energy demand over the DOD system voltage, and we have the days of autonomy. For example, this one they need 2 days, the system to withstand 2 days, and this load is coming from we calculate before 745, and our system voltage is 12 volt because less than 1 kilowatt hour. That's why we use 12 volt. 12 volt is sufficient. Okay, sufficient. And DOD here is 0.6. Then when we calculate, we get 207 Ah, okay, of capacity. Then the number of batteries in series, because system voltage is 12 volt, this is system voltage, and the battery use 12 volt, so we need only one of 12 volt batteries connected in series. Okay, connected in series to only one battery because our energy requirement less than 1 kilowatt hour. So the system voltage enough with the 12 volt. But for parallel, let's say we use this kind of battery. Okay, this battery provide us with 21 Ah, and in order to get the number of battery parallels, we have the required capacity that we calculate here, 207, and we divide into 21, then we get 9.85, then we round it up. Okay, round it up becomes 10 batteries. If we round down, it will be not enough to supply 207. It will be less than that. That's why we need to round it up, then become 10 batteries, 10 pieces of batteries. Okay, means that the total capacity we need here is 207 Ah after we consider to choose this battery with the DOD 0.6. If we find better battery, for example, the lithium blah 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 blah, that lithium one, then maybe can go to 70 or 80%, then it will lesser lah. I mean the total of capacity will be lesser than that. Then choose the battery, the battery that we need. Usually people using 100 Ah, minimum 100 Ah of capacity battery. Then you divide it with the total capacity over the storage capacity of the battery that we choose, then we round it up. Okay, so this is what so I told you, this is the simplest way to design the standalone system. This is the simplest way. The complicated one is be based on the SEDA certified, the standalone one. We have the reference book, but that one's quite old syllabus. But that one I need to discuss with Shawal because there's no persons here who have gone to that course. Okay, I will show you the cost after this. Okay, that cost, because it's expensive than the grid connected. Okay, so the number of batteries that we are going to use here is 1 multiplied with 10. We need only 10 batteries. Let's say our system voltage is 48 volts. If 48 volts, then this one will become 4 of the batteries. Then the series is 4, so become 40 batteries. If the system is 48, for example. Okay, this one very critical. The first mistake is made during the choosing of the appropriate system voltage from the calculated energy requirement. So this is I think this is the first mistake that person who newbies who want to install. This is the first mistake. First mistake, wrongly choose SV, system voltage. Macam wrongly choose SV kan, wrongly choose supervisor for PSM1 for example. Okay, so this is the first mistake. Then after that, we don't consider the inverter efficiency because you use AC, and don't take the overall general system efficiency that coming from the cable and charge control and so on, connectors, everything. So that one maybe don't consider that. It should be 85% or 80%. What we don't consider, we consider 100% correct. That's the second mistake. The third mistake, when we choose the battery, we don't consider the depth of discharge seriously. Okay, we're just playing with that. We don't really serious. That will lead. It will lead to the insufficient storage capacity in the future. I believe, I strongly confident it will happen. At that time, you start to meloncat, you are blaming here and there, suddenly. But at the first place, because we know nothing, we do nothing. We don't know nothing. We don't know anything. Okay, we know nothing. So and then we start to blame someone. That's why if we have this kind of basis, at least you can do your own calculation for the simple standalone PV system. Okay. Any question? Dia short lah.
Kenapa kalau parallel tu dia kena bagi dengan 21 saja?
Okay, kenapa parallel bagi 21? Because this battery we choose. Example lah. Example here is 21 Ah. Example capacity here 21 Ah.
Oh, okay sir.
If 100 Ah, 100 Ah lah. Just the example lah. Example.
Okay sir.
Confused Kenapa 21
Yes.
60% also because the example given here is 60% lah.
Oh yes sir. Itu saya ingat, tapi yang 21 ni tak tahu tiba-tiba.
Tiba-tiba out of nowhere lompat. Gitu lah. Battery voltage same. If you want to know the what we call it, the massive storage capacities of lead acid battery, the biggest capacity, and usually their voltage is not 12. Their voltage is actually sometimes only 2 volt. Yang capacity yang 1000. Like 38,000 Ah capacity lead acid ada battery macam ni. Usually the voltage is only 2 volt, not 12. Okay. Why 2 volt? Because 2 volt, the degrading of 2 volt is lesser than the grading of the 12 volt. 12 volt, when they degrades, they can go down until 10 something and 10 something, 12 to 10 something, quite 2 volts there. But for the battery 2 volt, sometimes maybe they drop only several 0.0 millivolt level. So it's more stable and capacity can be extend. The capacity can be withstand for longer time. Okay, that's why when a big capacity microgrid application, smart grid and so on, the storage battery banks, they are going to use the very extreme massive size of the storage capacity, but the battery voltage is only 2 volt. Okay, for us rookies, so rookies kita will be based on 10 volt because easy kan, easy. But for the cost of 2 volts, of course, they will need another 6 batteries in series in order to form 12 volt. So that's different cost there. But the stability is clear. Batteries should be configured at the system voltage. Make a drawing of your battery configuration. Small off-grid PV system usually use 12 volt as their system voltage 12 batteries. If 2 volt, 2 volt and 6 volt DC battery are used, they are configured in series. That I told you, okay. The stable one, for example, use 2 volt with 30,000. Not midi-Ah, it's AH. So we need 6 in order to get 12 volt. So if we want the 48 volt, so you need another berapa? Terempat. 24 pieces. But that one you need to consider the DOD is different, also the stability there and the voltage there. Okay, dia ada brand dia lagi, so that's the different story. Okay. For you, I think basis 12 volt standard 12 volt battery, because mostly the battery is 12 volt base. We have 6 also we have, but we don't use 6. Typical way we use 12 volt DC, right? And then before choosing a charge controller, decide the controller size, current rating. Mostly they are written like 10 AM charge controller, 20 AM, 30 or 40 and 60 and sometimes 100 amps of the charge controller, MPPT charge controller, whatever lah. Decide controller features. This one, for example, MPPT or PWM. This is common lah. I told you, please choose MPPT. In whatever reason, this is the best. Okay, this is the best controller, MPPT, right? And then controller need to be sized according to the system voltage, either 12 volt, 24 volt, or 48 volt. Like I told you, most charge controller can support these two system. It will automatically rotate when the voltage is near to 24. And then the one is 48 volt, usually separate. They are more to suited. They are what you call charge controller plus inverter. They are all in package. Usually 48 volt ni package with the charge controller. Charge controller with the inverter is package for the 48 volt system. Okay. Then sizing selection of charge controller. Okay, sizing selection of charge controller. Controller must be sized to handle both the maximum short circuit current from the array and the maximum demand of the load. Okay, remember the rated charge controller, the amps one must be bigger than that. Of course, you need to support with the short circuit current of it must be more than the ISC, STC of the module. Okay, if you less than that, that's the problem. They said here from the PV array, lah. If we have the multiple connection in parallel, so you need to consider that. So that charge controller must be able to support the maximum current from the PV array. Charge controller size range from 5 to 50 amps. We have 100 amps also. Many charge controller have the same charge and load output rating. Okay, controller is sized to accept 10 ampere of charge from the array and to provide a maximum 10-hour load output. Means that if we see the rated of the charge controller, usually they write like this, 30 amps MPPT charge controller. It means that the maximum input current from PV array is 30 amps and the maximum load current that discharge from battery also 30 amps, like that. So that's the meaning of that. Okay. To determine the array's current size, calculate the maximum short circuit current of the array and multiply it by 1.25. This is margin. Okay, again, this is the margin that we don't take exactly the 30 amps as it is. For example, if we have the parallel connection, then we get 30 amps in total. We don't take that. That's very dangerous. That's why it must be multiplied with 1.25. For example, 20 multiply with 1.25, then you get 20. Berapa ni? Kira berapa ni? Hello? 20 multiply with 1.25, how much is it? Boleh kira?
25.
25? Okay, 25 amps lah. So we don't consider 20 amps. We need to multiply with the margin as the margin side. Okay, we take that 1.25 lah. Ni around 35% lah, discount lah. 35% over margin is 25% from the original load coming from the PV array. That's the safer side. Okay, to determine the maximum DC load output current, calculate the maximum power consumption of all DC not AC appliances. Okay, determine the maximum DC load output current, calculate the maximum power consumption of all DC. Okay, DC load output current. Then divide this by the system voltage to get the maximum DC load and multiply by 2.5. This is the load output current rating in the amps. So we get power consumption that we get, for example, we have the system 12 volt and how many amps then? Or sometimes they written already 12 watt of the DC bulb. Okay, say that 12 watt macam mana? We have the rated one, and then after we get the power, then we divide into voltage. Okay, we get the power and then we get it to voltage, 12 volt, then we're going to get the current. Okay, multiply again with the 1.25, then we have that margin. So that we don't use exactly 20 amps. If our load is 20 amps too, we don't consider 20 amps, we multiply with 1.25 extra, 25% extra. Okay, this is how we choose the charge controller. The better one is using the bigger one. Even though our calculated load is 20 amps, if you see 40 amps, just buy it, no problem. Okay. So example of charge controller, they have the limitation actually. Limitation of 60 volt, for example, means that it can support until maximum 60 volt lah. Then maximum current is 10 amps. Then operational voltage, this one I told you, this is usually written in the charge controller. Sometimes they slash like this, so they have the bi-channel that can tolerate with these two system voltage type. But sometimes they separate. They say 12 volt different Shopee link, 24 volt different Shopee link. So please be aware with that. Okay. Then MPPT charge controller lah. Recommendation is MPPT charge controller. Though we don't know how exactly it performs, but it's okay lah. You take charge controller. Okay. Charge controller okay, but the inverter is different thing. Inverter you must find pure sine wave. So this is the VMP and this is the AMP. Maximum input voltage. Okay, sorry. This maximum voltage mean that maximum input voltage from the PV array. Okay. For example, usually this one can support until 24 or 48 sometimes. Maximum voltage is 60. So 60 will be regulated to the exactly following the system voltage of the battery. That's the work of the charge controller. Okay. They have a limitation lah, means maximum voltage 60 volt means that the series connection, they have limitation lah. Because if we connect the module in series, modules in series, so the voltage will be increasing. So this limit must be less than 60 volt. Okay, if more than that, it's not suitable to use. Then sizing installation of inverter. So is an inverter needed? This means that we need AC. We need to use AC appliances. Okay. For example, we want to use the TV kan. Even you living in the jungle, you still need to watch the game show every day kan. That's why we need the TV, we need the AC appliances. So when we need the AC load to be used, then we are going to need the inverter, because the inverter will invert the DC to the AC. Okay. The inverter must deliver the maximum AC load that you expect from AC device. So we calculate the AC load, total power consumption, multiply with the rated voltage of that inverter. For example, 230 volt. So we multiply with the 230 volt, then we're going to get the AC load there. Total up the power, divide and multiply this with 145. After we get the load, that load current, we must multiply again with the 145 in to take the 25% margin. Okay, for the safer side. Okay, because we are, maybe the calculation is not correct. Sometimes they have the plus. Okay, that's why we take the safety margin, which is the 25% from the original calculated AC load current. So this is the recommended inverter rating. So select desired inverter features. Okay, remember, we know how much load we need. For example, before we have the 300 watt hours of the AC load in watt hours. Okay, we have that thing, and then we multiply, we divide into the voltage. We divide into the voltage to get the load current. How much is it? Then again, we multiply with 1.25 in order to get the margin, to consider the margin. And decide the desired feature. And after that, we choose the inverter that you need. So we just start to window shopping or Google, Shopee, and so on. So we choose the inverter, and please remember to find the inverter with the pure sine wave. Okay, pure sine wave. Please find the inverter that written pure sine wave first, and then datasheet is available. Okay, you can check cross internet. Okay, not that just the description in the Shopee link or the Lazada is not enough. They can make mistake, or they just paste from somewhere. Then decide desired feature of the inverter unit. Make sure the wave shape. This is wave shape of the inverter unit that needs your application, which didn't find the pure sine wave word on the inverter. For example, maybe they have some data sheet, so written in 90% and operational voltage only 24 volt. This one also, again, don't make mistakes. Sometimes they have slash 24, 48. Sometimes in the shopping link too, they're different. 12 volt, 24, 48 separately. So please be aware, don't make mistake. Okay. Then minimum nominal power rating, total power demand is 200 watt over 0.9 inverter efficiency. This is the coming that from before. Okay, it's coming from before. Then you get the total watts. Okay, we get the total watt, because the indicator for the inverter is in watt. For example, 500 watt, 1 kilowatt, 5 kilowatt, 8 kilowatt pun ada. Okay, alright. Please find the inverter that have the datasheet that written inverter efficiency. You need to Google banyak sikit lah. Okay, Google banyak sikit. Cari inverter yang ada datasheet. Okay, yang ada datasheet. Yes, now we have the hybrid inverter kan. It's okay. You can take the datasheet and you check the spec. Okay. The better one that have from 12 volt, 24 volt and 48 volt, everything can be compatible with all majority of the system voltage. That's the better one, but usually the price is higher lah. Okay. Alright. Any question? Ngantuk pula. Saya mengajar ngantuk. Korang yang dengar ni apatah lagi. Any question? Apa senyap?
Ya, saya.
Tak ada. Sekejap. Panggil orang. Panggil orang Yusuf. No, ada hantar mesej apa ke? Alamak, hantar mesej apa tak dapat nak tengok lah. Okay, doctor, protection like surge protection is used in panel or inverter. Surge atau what we call that as the surge protection devices. Okay, SPD. Okay, SPD we use connection modules. Okay, modules in panel in panel. At the same time also inverter they have the grounding. Inverter also have the part for the grounding. So that grounding also will be connected to the SC SPD also. They have the SC SPD. DC SPD also have, SC SPD also have. Okay. But mostly very popular connection is on the DC side on the DC side because they have the 3 pole there. Okay. So one I forgot the sequence plus and minus wait plus and minus, plus and ground, and minus and ground. Like that I forgot the condition. The sequence also I forgot. So that's the use of the SPDs for the lightning protection. Okay, Muzamil. Alright. Any other question?
Doktor,
Yes.
dan ini untuk standalone kan. So kalau let's say kita pasang standalone untuk sekarang ni kita akan ambil ada NAM rakyat kan?
Bukan. Standalone bukan plan NAM rakyat. NAM rakyat untuk GCPV sahaja. Kejap lagi lagi saya tunjuk.
Okay.
Tapi nak tanya pasal tu pasal plan-plan tu Okay, standalone tidak ada plan apa-apa. Standalone, if we plan to do standalone, totally standalone, bukan Serco, that's pasang sendiri manage, sendiri pasang semua, TMB tak kacau. Tapi kalau main Serco dia ada tap sikit dekat DB tu. But that Serco also TMB will not interrupt because it is after the meter, after the distribution board. So after distribution board in the house, TMB will not touch. TMB only touch on the meter only. The TMB meter only until that level. If you try to loop, you bypass and short, you do bypass, stealing the electricity, that one will be fined by the TMB masuk mahkamah. Itu the court lah. So because you are touching the TMB meter. Orang curi line, curi elektrik semua tu kan. Stealing the electricity, that one will be charged at the court by the TMB. That one you touch the meter. But after the meter, TMB will not enter. Whatever happen, they don't care. Okay? That one wireman lah.
Okay, baik.
Okay. Before, I think today also, I want to show you the plan that we have in the Cedar. But that one, so maybe I will finish today. Sebelum tu, before that, let's do the very simple connection of the PV module. I mean the standalone system the very very super simple lah. Okay, very very super simple. Okay. Boleh ke? Semua boleh fokus ke ni? Jadi kan aku tak hantar recording aku dah tak upload lama. Faizuddin. Okay, Faizuddin.
Okay, Doktor.
Boleh
Boleh.
Irfan.
Boleh, Doktor.
Boleh Fadilah.
Boleh, Doktor.
Syahira. Nampak mu Syahira Senyap terus. Tak apa. Okay. So, let's connect all the things. Sorry, we don't have the hardware in front of us because we are online, but still the very basic of connection. Okay. Basically, we have the plus and minus from the PV module. So the plus one, we are going to connect with the plus one. Okay. So everything will be interconnected to the charge controller. Charge controller is just the controller, is controller that control the output from the PV, the charging and discharging current inside and outside from the batteries. And the use of the load also is determined by the controller. It's controlled by the controller. Okay. Basically, the controller, MPPT charge controller, or PWM charge controller, they have several holes. Okay, several connection segments to the device. Okay. By default, they have the 6 holes here. Okay, 6 holes here. They are written in detail usually. This is for the PV. This is for the battery. And this is for the DC load, for the load. Okay, this is default setting. Okay, the connection is very super simple. Okay, you have the plus here and you connect to this plus. Usually this is the plus plus. Okay, this is plus. Let's say we have the minus cable here, so you just connect it to the next segment, which is here, and this is the minus. Okay, in the middle, sometimes we have the blocking diodes here. Okay, blocking diode here, and sometimes we have fuse. Okay, fuse for both AC, I mean the plus and negative. We have the fuse for the plus and negative. But recently I heard it's enough only to put in the positive only, because they just cut at the plus only is sufficient. But before that, plus and minus are equipped with this fuse. Okay. Then after that, it comes to the charge controller, and then this one we connect it to the plus of the battery terminal, and this is negative of the battery. So let's say this is plus, this is negative. Okay. And because like I told you, battery also when you connect, sometimes it will create sparks. Sparks. And especially for those with the higher capacity. So it is better for you to put the MCCB also here. MCCB DC. Okay, DC MCCB. In order to cut, if we keep the off, so whenever you connect cable, it will not create any spark, and there will be less damage, or there will be less risk of creating some spark or arc, something like that. If we do it parallel, that's one also very risky, and please be careful if we try to do the parallel, because we want to multiply the capacity kan. So means that you are going to connect plus to the plus okay. When you try to complete the circuit, and it will create sometimes spark. Okay, that one also you can put in the middle with the breaker. Okay, breaker in middle, or during the installation too, please make sure you wear the insulator, you wear all the helmets, not helmet, the visor, something like that, and wear proper attire to avoid any accident. Okay, alright. Then there's 2 methods to connect the inverter if we use the AC. But before that, if we plan to do the DC load, okay, DC load, for example, we have the 4 bulbs here, and we want to separate it, the what we call that, we want to separate it, the switch. DC load, 12 volt use, so you just take the plus here, take here. So all are loop, okay, and then so you can connect it, you can put switch here, MCCB also okay, or you put the Swiss, any Swiss, I forgot the symbol for the Swiss maybe like this, forgot. And this one like that, so this is Swiss, here, Swiss. Okay, and then this is for the plus. Then you can put one MCCB here one light in the house, AC. So this CMCCB, for example, you put light in the house 6 amps, 10 amps, okay, like that lah. Okay. Then after that, they're going to have the separate switches, and then the negative one will connect it at the back here, and all are parallel also for the negative. But for the plus one, if we want to have the separate switch, so you put each parallel wire cable tu, you put one switch. Then you can control one by one loads. Okay. Alright. Then if we want to proceed with the inverter, my suggestion is to use ST-2. There's some people who directly connected to the battery, and then they put the switch here or fuse. But I think that one quite risky because this inverter will not turn off if it can goes to over discharging condition. So it's very dangerous. So the better one for me is to for example this one plus the red one's plus is connect also here, and then this one also will connect here. Then you can put in the middle also this MCB. Okay, this MCB. MCB you put there, and then you can use this sometimes they have the USB, depends on you lah. Sometimes they have the appliances, so you can directly use for your AC load negative and plus and negative. And the inverter also sometimes they have cable or section grounding, so that one you directly connect it to the ground. Okay, connect to the ground. Usually they have proper one, they have the earthing concept. This one also you can put switch, okay. Why it's connected here? If the battery is going to the lower state, it will totally disconnect all the loads. So this only can be done if you connect it to the charge controller. So that if less than that, not enough battery, it will totally cut off here. So there will be no discharging will happen because once the voltage reaches the lowest button that we set, it will turn off the load. So the load will not turn on. So it is safer. If you connect directly, you can get the continuous power supply, but the problem is it will not trigger if the battery is getting very low. Okay? Even though they have the limitation here for the inverter, but basically we will overlook of it. Okay? Because they don't have any indicator, they don't have any safety features that stop. Mostly they are not equipped with that. But the hybrid inverter, I think hybrid inverter for the standalone system, they are suited with the good controller kan. That one is different lah. Okay. Alright. Boleh tak? Sambungan mudah. Any question? Oi, mantap betul ID Idahan. Any question? Oi, senyap semua. Tak ada suara. Fahim?
Ya, sir.
Okay. Boleh?
Sir, katanya attendance saya buat
Oh, lama lah saya tak ambil attendance. Biar.
Okay.
Nanti kalau saya minta ni sama pagi lah ni. Kita bagi sikit lah golongan ni. Christopher, okay? Christopher?
Okay, sir.
Okay. Okay. We finished the standalone chapter. Okay. Officially. So we finished cover the standalone chapter. But the last chapter will be actually there's we call that, I forgot the name of that. But not really critical chapter lah. There's three items on there. Emerging renewable energy system technologies. Like that. So there's a topic of the hybrid system, and the topic of energy management, and also they have the topic of subtopic of the smart grid. Okay, for me, I don't have specific notes for that because that is one more to the general knowledge. You can Google actually. It's actually the route for the research. Okay, research part. For example lah, I go for the first subtopic, which is the hybrid system. Okay, hybrid system. You can, if you go to Science Directs, very a lot. You just type, for example, hybrid system PV, then going to have the lot of lists of the system published papers regarding the hybrid system with PV. So I just pick up one example. Okay, regardless of the name of the journal, even the cleaner production, whatever it is, I don't care. Okay, here is the effects on the battery life and cost in PV wind battery hybrid system. Okay, the keywords here is the hybrid system. Even you look at the title also, we know already what is the meaning of hybrid system. Hybrid system means they're going to have more than one energy system. Okay, more than one energy system. Renewable energy. Okay, renewable energy. They have PV, they have wind, and they have battery by default. I think mostly they're going to have the PV. PV is a must for them. And then wind, also not all the system they have the wind, because the wind there's the limitation. It is told that it has been told that the wind energy system will be more effective during the night. During the day is PV, during the night is wind. Maybe the pressure of the night during, I don't know lah, maybe lesser than that, something like that. But this philosophy and this it has been told that the night, the wind system are more efficient. But the wind system, there's limitation. It need to be at the place in the high in the hill or near to seaside that have the windy condition. And if we don't have the windy condition, we don't have the windy environment there, good windy environment there, that's very difficult to install the PV. It's not worth. Okay, then we are going to have the battery. For example, there must be a battery in order to store the energy. If not, all the generated energy during the day, for example, cannot be used during the night if we don't have batteries. Okay, that's one thing for the hybrid. I think here, I'm not sure they're written here or not. This one, they focus only on battery, wind, and PV. Okay, and then they have the battery and the storage system. It's actually sometimes you can see the paper that have mana tah? Sometimes they have fuel cell. Okay, sometimes they have the several thing. Biomass also recently have what we call, ternampak tak ada. They have the diesel. Okay, they have the diesel also. Sometimes they have the diesel as the backup. I mean the genset. For example, but the genset is not that. If the small scale, maybe 4 kVA or 6 kVA of the backup, that is the last resort. If during the thunderstorm, confirm the PV will not. It's rarely generated any energy yet because the thunderstorm. At the same time, also wind also maybe is not applicable because the wind from the storm is very strong. So there's limitation of the wind turbine. Limitation specification depends. It will also break the fin if too fast. If the wind is too strong, sometimes you could check YouTube also. It destroy the fins, everything, and the propeller. I mean the the fin. So that's basically they have the diesel. Okay, diesel as the backup last resort. If nothing is there, they just put the diesel like the normal genset happens in during the electrical shutdown. So that's the thing. Okay, and then energy management. So energy management from the wording itself is to manage the energy. You call it energy management. So there's a lot of recently Savvy Integrated PV BSSS system for residual. This is the online energy management tool. Usually we have PV and BSS is to control the energy. Control energy. They have the algorithm, of course, the algorithm and so on. Usually they're playing with the batteries. Okay, when they have the energy management, I believe I can say that almost 100% they are suited with BSS, or we call that as the battery energy storage system. When we talk about energy management, definitely there will be battery there because they want to efficiently manage the energy in the battery to use to the load to avoid any interruptible situation kan. So that's the necessity of doing the energy management algorithm. Okay. Also, the example fuzzy logic based energy management. So this energy algorithm is using the fuzzy logic. Maybe some of you are using the fuzzy logic and grid connected hybrid PV system, and they have the this bus and boost converter and so on. They have the algorithm there in order to manage the energy very well, and must be definitely have the batteries. Should be have the bidirectional battery. They have the battery there. So the necessity of energy management is there. For me, it's not the. It's still the research topics here. A lot of people also publishing these days. Even you look at the science there, you can see the kind of things. I mean, this 4 chapter we don't include it in the exam maybe, and then this more to reading okay, for your own knowledge, for the research, okay. And the smart grid PV. So the third one is the smart grid. So smart grid usually they have suit with a lot of energy resources, renewable energy resources like PV, hybrid system, wind, and they have battery storage banks, very high capacity of storage banks. When we talk about smart grids, the target is the very large capacity of the storage banks. Okay, here I'm not sure written here tidak. Yang dalam ni tak ada contoh. Tak ada contoh dalam ni. Preparation by other feature. Okay lah. Tak ada tulis. But the smart grid is just the distribution system. Smart grid is the distribution system for the community. They have even the microgrid, mini grid, and the smart grid. There's grid. It looks like we don't rely on the TMB. We create our own system. We get our own storage, a big, massive storage banks, and we have the energy resources from renewable energy because the smart grid is very applicable and desirable in the island. Because in the island, it's very difficult. For example, if we know we have the TMB there, we have the substation there, but if we go to the renewable energy and totally renewable energy, they have smart grids too. They are depending on the renewable energy sources. They're fully utilized. They're fully harvesting from the wind, PV, maybe biomass. Okay, from the tidal, and then the very large capacity of the battery banks. Okay, we call that as storage banks. Okay, here's an example for that last chapter. Chapter 6 maybe. Any question? The end of chapter 6. It's about readings. Tak ada? Ada soalan ke? Kau ada soalan tak?
Tak ada.
Tak ada Okay, saya pergi last. Saya nak tunjuk juga yang Seda punya website tu. So ini kita dah habis. So we finish cover all the things. Last but not least. Okay. So this is the website of the Seda. Okay, this is the website of the Seda. You can go to the seda.gov.my reportal like that. And then from here you can see there's some information here. And then there's the NEM, feed-in tariff, LSS. Okay, LSS is stand for the large scale solar. I think the size minimum is 1 megawatt. FIT is no longer available, but maybe there's some reading there you can go to read. And the Selco self-consumption. So this is the recent trending. Other than NEM is Selco. First, you use your own energy on PV system, generated energy from the PV system. If not enough, it will trigger to the TMB. Then you start to use from the TMB. So the significance is to reduce the energy. To reduce the electricity bill, of course, because you use first your system. If not enough, then you pull it from the TMB. I believe there's a ATS system, automatic transfer switch, or maybe they have the smart algorithm or smart switch that can turn that can change the power supply from your PV to the TMB without any interruption. Maybe I don't know the recent technology. I'm not focusing on the Celco yet. Okay, and then they have the RE incentive. I think there's a plan of Malaysian target kan. Macam promote pula kan. Okay. So when you click on the NEM metering, it's the same. It comes like this. Okay. Yeah. Okay. It becomes like this. Okay. The recent net energy metering plan is the 3.0. So net energy metering 3.0. Under the NEM package, GNM package, so before that, sebelum tu apa yang penting kat sini? Okay. Okay, there's the quota allocation there, and there's some package there, NEM Rakyat, NEM Government Program, and Nova Program. Okay, there's a quota allocated by the government. For example, NEM Rakyat is 100 megawatt per year for all quota for the Malaysians, and the new government another 100 megawatt, but for the Nova is 600 megawatt. So it relates to the company. Okay, it's still active until the end of next year, 2023. Okay, and then apa lagi? 3.0 is because from the 2.0 lah. Okay, 2.0, and then the okay. Tak ada. Alright. So there's some package here. 3 package. NEM Rakyat. Okay, NEM Rakyat. Eligibility criteria maximum quota is 100 megawatt AC. Okay, megawatt AC, not DC, megawatt AC. And there's the capacity limits. Single phase only 4 kilowatt AC, 3 phase only 10 kilowatt AC. This is used for domestic house lah. Okay. Registered consumers of TMB, independent measure or person planning to be a consumer of TMB who have not participated in any operation solar. Domestic consumer means a consumer occupying a private dwelling premise which is not used as a hotel. Ni domestic residents. Okay, resident. Like us like us. Okay. Like me, like you. If you want to install the NEM, of course you need the quotation from the supplier atau ulat solar di luar sana, company solar. A lot of solar company there who doing the consultation about that. Please ask for the quotation first. I think quotation only free, no need for the payment. Okay, they will give you the quotation, and they ask you how much is your electricity bill. Okay, electricity bill and so on. So you give the electricity bill, and then they will ask, for example, if your bill is less than 300 ringgit, it's not worth. Maybe 350 ringgit and above, that is worth for you to use the NEM. Okay, that's the normal consultant will say that 250 ringgit also not enough. Maybe if you use more than 400, then it's worth for you with the ROI and so on. Okay, so the single phase one is the 4 kilowatt, but for those who have the 3-phase connection, 3-phase TMB, and then you can goes up to 10 kilowatt AC. Remember, 10 kilowatt AC is the size of the solar farm and so on. We're going to say the AC one but the DC must be more For example, if 4 kilowatt AC, usually 4.5 or near to 5 kilowatt DC. I mean the solar module's capacity is 4.5 and above. But the total energy, the total power that you export to the TMB is 4 kilowatt. Okay, that's the meaning. And then apa lagi kat sini? Okay. About the way they pay you, the way the TMB pay you, they come to install. I mean the buyer is the TMB. Okay, the buyer is TMB, and the grant quota dia kata is from the SEDA, the authority, the KETA, SEDA give the quota. Power purchase agreement, there'll be contract there, then you need to deliver how much what is the target, who's the buyer, and what is the ROI. They will written in that and all that document lah. Okay, then under this program, any excess energy generated will be exported to the electricity grid, which is the TMB grid, and will be paid on a one-on-one offset basis. Okay, I think before 2019 kot, their rating is very low. But after that, I still remember YB Yubihin, if I'm not mistaken, they revised the contract, they revised the policy. They said it will be paid by one-on-one offset basis. Means they will pay you exactly like the TNB tariff rate. If the first 200 kilowatt hours you pay, I think maybe 28 cents, for example, and then the next 10 kilowatt hour, the next 100 kilowatt hours maybe 33 good 38 33 forgot, and then the next after that more than 300 kilowatt hours you start to pay 55 cent per kilowatt hour, for example. So how much you generate energy, you will get what you generate exactly with the tariff rate. Tariff rate. So it works lah, sebab dapat tariff rate tu bagus lah. Okay, berapa you generate, how much you generate, how much you pay to TNB to buy, and PNB will pay for you, will buy for you with the same amount, with the same tariff rate. So that's why NEM is still relevant here. Now become relevant, and that's why you can see a lot of person, a lot of domestic person, I mean residential also are installing that one. For example, we have new staff, but not staff. There's one staff asking me to check either the NEM is good or not. I need to, I can't disclose the name, but the size the quoted is for, I just give you the figure. This one company quote with this price, 4.5 kilowatt DC system, which is to deliver 4 kilowatt and become maximum single phase 4 kilowatt with the price of 21,000. Okay, this is the recent, I think last week. The brother forward to me. They asking me, and is it relevant? Is it okay? Okay, is it worth? Asking me, and the ROI is around 6.16 years, if I'm not mistaken, 6 years and more than 6 years lah. Okay lah, 6 years return of investment to within 6 years. Means that all the installation cost of 21,000 that you spend, you are going to start to feel to, what you call that, you start to feel the profit after 6 years. Okay, after 6 years, you try to generate income. You're going to generate income after 6 years. They call what we call that return of investment. All the 21,000 you spend for that 4.5 kilowatt DC will be returned to you, all the costs after 6 years. Okay, right? That one, brother, 21,000 something with the 4.5 kilowatt DC of system. So because the single phase is 4 kilowatt AC, so that's the, for me it's quite higher lah, because that more than what, 4,000, almost 4,000 for kilowatt 4,000 something, I think 4 kilowatt. For each kilowatt to cost 4,000, is quite expensive, I think. You can get lesser than 3.6, 3.5, so we can get. That's why you need to ask a lot of company to get the quotation before you decide to install. Please ask. Maybe this one also you can discuss with your parents kan, if you're interested. But first you do the background study dulu lah. You study dulu, you ask many things. Okay. One more thing is it will return to you. They are paying to you. They are giving credits for the next month. You know, this month's generation will be brought to the next month generation, and the next month credits will be deducted to your electricity bill. For example, this month I generate 250 ringgit. Then, siapa tu? Siapa tu? Misteri. Okay. If you generate, for example, our bill, okay, this month you get 250 ringgit generation of energy, worth 250 ringgit. Next month, for the next month bill, you use 300 ringgit, for example. So they will deduct 250, so you need to pay only 50 ringgit. Okay, 50 ringgit. But I'm not talking about the kilowatt hours. I'm not talking about the price actually. It's about kilowatt hours lah, but the conversion is to ringgit lah, like that lah. Okay. But if you generate 300 kilowatt hours, but next month you use actually only 100 ringgit, 100 kilowatt hours kan. So the remaining 200 kilowatt hours will bring to the next month. Means that next month tu 100 ringgit tu free. I repeat, this for example, this June, you generate 250 ringgit words, I mean the equivalent value with the kilowatt hours, 250 ringgit. Next month, you use only 100 only. 100 aircon maybe use less than 100 ringgit on your electricity bill. So next month too, it become free because you have the credits of 250. So you get the balance of 150 ringgit, right? That 150 ringgit will bring to the next month. If the next month also you use the again 100 ringgit, so you have another extra 50 ringgit plus next month generation block. Okay? Then if we use lesser, then it will keep bring until 12 months. Okay, 12 months. Okay, 12 months. So credit should be allowed to roll over for maximum 12 months. If 12 months also not finished, burn lah. The credits burn. Then start with the new cycle. And that's why if your electricity bill is very less, 100, 150 ringgit, 250 ringgit is not worth. I'm afraid the 4 kilowatt also will generate more. And at the end, you bring the credits until 12 months also, it's not worth. But if your electricity bill is extreme, 450 ringgit, 500 ringgit, because maybe 7 aircons running in the same time, 500 ringgit, even though you use 4 kilowatt hours, you are going to feel the energy saving. This month maybe 500 kilowatt hours kan, I mean 500 ringgit. But next month after install, generate, you only pay 250 ringgit. So that is the 50% energy saving. Okay. All the things, you are going to get the 100% profit after ROI finish, which is just now 6 years. So after 6 years, then you start to feel the profit there, even after 6 years lah. Okay. Boleh faham ke? Ke aku cakap seorang? Faham ke?
Betul nak tanya.
Ya.
Lepas habis one to one tu, macam mana pula dia punya tu?
One to one macam mana?
Lepas habis one to one tu dalam masa setahun kan?
Dia reset.
Habis tu?
Reset.
Maksudnya?
Kalau contoh kan, dah 12 hours tu, dia ada kontrak tu, 12 months tu dah habis, walaupun ada lagi balance credits, contohlah ada kredit lagi berapa kilowatt hours yang tak diklaim kan sebab kau tak guna, dia akan burn. Dia akan start baru. Walaupun ada contohlah words dalam RM300 ada kredit, tapi sebab dah lebih 12 bulan, dia akan burn terus, jadi kosong balik. So masuk tahun kedua tu kira balik dari awal. Kira balik start dari kosong berapa. Faham? Faham ke?
Faham. So dia proceed pada tahun yang baru pula lah.
Dia kira baru. Habis dah kredit tu kira habis. Lepas tu start tahun baru tu dia kira balik yang lain lah. Rugi lah.
Balik one to one lah macam tu ke?
One to one tu maksudnya kalau 100 kilowatt, okay, 100 kan 200 kilowatt hours yang pertama tu, 200 kilowatt hours yang pertama rating dia saya rasa 28 cents ke? Betul? Kalau kita beli tarif biasa. Kan? Betul tak? Then kalau kita generate 200 kilowatt hours pun, price yang TNB akan beli pun dengan harga yang sama. Kau faham tak? Kenapa saya cakap macam tu? Kalau LSS large scale solar, different. Large scale solar, they don't have the 101 basis. Large scale solar tu, tak salah saya setakat ini, per kilowatt hour, TNB hanya beli only with the several cents. Maybe 14 cents, 14 or 15 cents. Faham? Kalau LSS tu. Makna kata rugi lah. Rugi lah sebab kita bayar elektrik pun 28 cents. Tapi bila yang large scale solar tu, less than 20 cents per kilowatt hour. Itu bukan one to one basis. Itu memang rate dia dah fix itu. Memang rendah betul lah large scale solar. Boleh ke?
Boleh.
Tu maksudnya one on one offset tu yang tu. Tapi itulah dia kalau generate banyak tu, dia akan pakai rate yang tinggi kan. Tengoklah, ikut tarif rate punya standard tu. Saya tak ingat sama itu. 200, 100 kan. Dia ada sengat-sengat tu.
kata kalau macam NEM Nova,
Ya.
dia ada TNB ada tetapkan kadar charge tenaga macam berapa persen?
Nova ke apa?
NEM Nova.
Nova sekejap. Tak apa lagi. Okay, Nova dia ada yang ini dia ada, dia boleh tolak. Yang ini kita boleh forward credits tu kepada account. Dia ada kategori A dan kategori B ni. Yang ni, Nova ni. Dia boleh forward. Yang ini rate dia macam mana? Dia bukan one on one ni. Alamak, tak ada biar pula. Sekejap NEM. Sekejap. Ini fee dan tarif. Alamak, 53 lah. Rakyat yang tadi, and then for the new government, kita pergi new government dulu New government ni masih lagi one on one. Okay, masih lagi one on one, but maximum capacity this new government is for commercial. Okay, NEM Rakyat for the residential atau domestic rate. Yang new government is for commercial, but there's limitation. Okay, limitation not more than 1 megawatt lah. Okay, not more than 1 megawatt. Lepas tu dia ada not exceeding 75% and so on lah. Dia ada limit. Low voltage consumer not exceeding 60% of use rating. Okay. Yang ini registered semua sama. Yang ini for the company lah. Okay, dia for company. One on one masih lagi. Masih lagi 12 months.
Oh, yang ni dia punya maksimum demand dia tak boleh lebih daripada 75%.
Betul. Tapi size capacity dia tu 1 mega. Kalau tadi tu sikit kan, single phase 4 kilowatt, yang 3 phase tu 10 kilowatt. Tapi yang government ni 1 mega. Sungguh pun begitu, dia ada limitation dia. 75% dengan 60% untuk low voltage dan juga medium voltage. Ini more to commercial lah. Tapi masih lagi one to one. Okay? One to one basis. Kalau Nova, on the Nova shall be consumed and designed primarily for self-consumption. Any excess energy is not consumed at the premise where the PV station is located due to operational constraints or monthly may be exported through the supply system under one of the following categories. So additional excess energy tu not consumed value should be credited to the account of the Nova consumer to be used to offset the bill payment for the next billing period. Okay, satu ni kita guna balik kita punya kepada kita punya account. Unit price of the exported energy billing period to supply will be based on the average system marginal price. Okay, ni saya tak berapa pasti lagi. SMP ni tengok balik. And then itu yang A. Yang B tu dia boleh forward. It's not consumed by Nova, may be exported by the supply system to up to 3 designated premises. Value exported should be credited to account of such to be offset. And unit masih SMP, tapi syarat dia designated premise of Nova includes premise use operate only on subsidiary company. Contohnya Syahiman Solution Sdn Bhd, bawah ada Syahiman Food, Syahiman Electronic, Syahiman Mechanical. So boleh forward pada subsidiary company je lah. Dia tak boleh forward tiba-tiba ke TMG. So dia tu boleh forward lah. Kredit tu boleh forward kepada yang kecil-kecil. Yang ini tak tulis pula one to one.
Yang ni ada maximum demand sekitar berapa persen ke dia pun tak ada.
Ni tak tulis pula. Ke aku tak boleh scroll. Ni average S&P is a monthly average S&P for the daily period between 7 hour to 9 hour in the preceding calendar month. Ini kena tengok betul ni. S&P ni is defined as the guideline for the single buyer market. Ini kena tengok pula. Saya tak pasti, saya tak detail lah. Maksudnya ni bukan one to one lah basis. Dia ada syarat lain lagi lah. Kena tengok dia punya polisi ni. Boleh?
Okay, boleh betul. So kiranya nak pakai Nanova ni make sure consumption tu more than 1 megawatt lah.
Dia tulis bawah tu. Ni mungkin large scale lah ni. Ni lebih pada large scale lah ni. Sebab tadi dia punya kota dia bagi sampai 600 megawatt. Dia banyak. Yang ni banyak sikit lah kota dia. Dia tak straight. Dia tak tulis pula kan. Okay, last. Okay, last. Sorry, nampak dah ni. Last. Ini yang saya nak tunjuk. Ini kalau Google juga, you just type Google DCPV System Design Course. This is what I'm saying. The SEDA Certified Designer Chapter Grid Connected tu adalah berdasarkan daripada hasil the content of the teaching. We are following the book that comes from this course. Okay. SEDA Malaysia Grid Connected Photovoltaic System Design Course. Okay. Training punya place ada 2 tempat. UiTM Shah Alam and also Selangor Human Resource Development Center SHRDC. The fee is considered cost material. Okay, ni dia punya syllabus code. Okay, ni saya nak tunjuk lah dia punya price. Local participant is 5.66,000 ringgit. And repeat theory, by the way, the passing marks is not 80%, 40%, passing mark is 90%. So kalau less than 90% fail lah, fail. Tapi kalau 80% and above boleh repeat, you can resit for the exam. But if you less than 80%, kalau less than 80% marks, tak boleh repeat, kena ambil balik. Okay? Yang ni adalah dia ada modul dia, ada sitting exam, dia ada teori and juga practical lah. Okay? I think course dia ada harga-harga yang berbeza-beza lah kat sini kan. So nak cerita sekarang 5.66 40 cents. Okay, this is for the SEDA yang company yang perlukan benda sebab design or DCPV tu, even though they're using PVCs for design, but there's the part of the endorsement must be made for the person who have this SEDA certified. Inilah yang saya nak ambil sangat tapi tak ada budget. Okay. One more thing, it's actually not only the DCPV and they have also DCPV for wireman, installation maintenance. Okay, one more. Last, OGPV system design course is the off-grid. Okay, off-grid system, off-grid PV system course 10 days. Yang just now tu 8 days. This is for the, I told you, the SEDA certified one. That's why I didn't teach, because we don't have the recent material for the SEDA one. Because the book is only can be accessed for the persons who going for that training. They are not sold online. Okay? And the problem here is the price itself is 7,000. Lagi mahal daripada JCPV. This for the OGPV, off-grid or standalone SEDA certified. Okay? Lepas tu dia adalah receipting price kan. Itulah passing marks pun quite high. It's 90%, I think it's the same. Okay. Itu saja kos dia. Yang saya duk sembang berbuih-buih sangat tu. Ini saya nak masuk inilah. Yang saya mendoakan kok ada rezeki kan dia bagi installment. Yang inilah that cost 5.6,000, almost 5.7,000 ringgit. Okay. Itu saja. Okay, energy efficiency ni RIM kot. RIM pun ada juga. Tak apalah ni korang Google lah nanti tengok nanti Yang ni energy manager. Biasa. Tak apa. Tapi yang penting tadi tu yang itulah system design course. Okay. Sorry. 4 already. No question kan? No question. Thank you. Alright. There will be no class next week. If something happen, if any detail. Oh, sorry. One more thing. Sorry. We are going to have the quiz 3 and quiz 4 this week, like I mentioned before. Okay, quiz 3 will be open today until Friday. Friday 10 a.m. maybe. And then the quiz 4 will start from Friday 10 a.m. until Sunday night. Okay, Sunday night. So quiz 3 and quiz 4 will be on this weekend. We'll start from today for quiz 3 and quiz 4 will start on the Friday. Itu saja. Lepas tu please don't forget your assignment And for those who lab submission, I don't know, already late. Okay. Thank you. Sorry. Taking a long time.